So hi everyone, I'm Leo and I'm in internship in UBERCUN laboratory, supervised by Mathieu Hébert, and I'm in partnership with XLIM and Lunel Simno. So the goal of my internship is to use a virtual Gonio photometer to capture the BRDF of water film on a roof surface and to evaluate the loss from age effects. So I'm in partnership with XLIM because they developed the virtual Gonio and help me to understand all parameters of the virtual Gonio. And I'm also in partnership with Lionel Simoneau, who brings us a knowledge for the results obtained thanks to this expertise. But what is the BRDF? So the BRDF is a physical quantity that fully characterizes the reflection of the light on the surface of materials. Its measurement is an indispensable tool for the measurement of appearance because it allows to know in detail the signals that enter the eyes, like shape, color, brightness, darkness, etc. So the definition of the BRDF is reflected radiance, so depending on the reflected angle, wavelength, and the polarization of the light, divided by irradiance of incidence, depending of angle of incidence, wavelength, and polarization of the light. And on the right, I put an example of BRDF with an hemispherical view. It's a flat representation. And I will explain later the parameters I'm changing to quantify my loss from HFX. So for my surface that I study, I have two interfaces, and between those interfaces there is a water. E1 is an air-water interface, which is not roof, and E2 is an water mirror interface where the roofness of the surface is controlled. The goal of my experiment is to characterize edge loss when one modifies the distance between those interfaces, the roughness, and the incidence angle. So sigma characterizes the roughness of those interfaces, h is the distance between the interfaces, and phi is the azimuth angle, and theta is the solar angle. So since we don't change the roughness of E1, so I call sigma the roughness of the surface E2. So now what is the virtual Gonio? So the goal of a Gonio photometer is to measure the BRDF of a surface. It's a high precision tool because you have to play on the angles of incidence and reflection to get the BRDF. So XLIM has developed a virtual Gonio to use a model that we want and to reduce the time to acquire the BRDF. So you can see a real BRDF on the right top. For our virtual Gonio, we need to specify the parameters of surface. So the number of interfaces, the roughness of each interface, and the distance between each interface. Next, we need the orientation of our collimate incidence beam and the number of samples sent on the surface. So we can also change the sensitivity of our camera. And in output, we get three images that we call L1, L2, and L1 plus L2. So L1 is only the reflection on the first surface, on the first interface, and L2 is the rest of the ray. And L1 plus L2 represents the real BRDF of the surface. So for the results that I present to you, I fix the thickness, theta and phi. So H equal to 100 micrometers, phi and theta equals 0 radian. And I change the roughness of E2 interface. So sigma equals 0.1 is a roof surface, and sigma equals 0.25 is a very roof surface. So you have to be careful about the scale, which is not the same of all figure. So you can see on L2 and L1 plus L2. But I'm working on it. So one can see that L1 for the both configuration is the same, which is normal because we didn't change E1. And for L2, we can see a dispersion of energy because the BRDF expands much more when the roughness is increased. And so we have a diminution of maximum energy. For the months that I have left, we want to quantify the loss from age effects using another parameter that Gonio provides us, the energy. So we have the energy for each images, so L1, L2, and L1 plus L2. And energy can be quantified in relation to the incidence angle or thickness or roughness of a second surface. Another way is to change the structure of our surface, like changing a mirror with a lumbation material. Thank you for your attention.